Page 2. Here's our first example where we do not have a 0 yet. So our first step is get a 0 over here. Easily accomplished by subtracting 22 from both sides. Okay? And this is not a nice 1x squared, so we use the AC method. A times C will be negative 66. And now I need some numbers that add up to 5 and multiply out to negative 66. I'm thinking 11 and a 6. And if I make the 6 the negative, those will now add up to plus 5 and multiply out to what we got from multiplying A and C. Multiply out to negative 66. So I'm going to write 3x squared plus 11x minus 6x. Maybe that's instead of the 5x. And minus 22 equals 0. And I got these two terms and these two terms. Common factor here is just a x. X times 3x plus 11. Common factor here, minus 2. Minus 2 times 3x makes the minus 6x. And a plus 11, that'll make the minus 22. And now we've got our common binomial factor, 3x plus 11. And the other factor will be x minus 2. As I said yesterday, notice the very important two sets of parentheses and the signs in the middle there, where they came from. What are the solutions? Negative 11 over 3 and a plus 2. That's that. Now, we've seen this one before when we were just talking about factoring. This does not factor. It's a sum of squares. This has no real solution. And I could also mention this to you. If I take away 49 from both sides and then divide by 9, we've got this little fraction. The important thing about it, it's a negative number. This is saying something times itself is going to come out negative. Do you see that that's impossible? Because a negative times a negative is going to be a positive. Never ever come out negative. And a positive times a positive, of course, is going to come out positive. So this situation is impossible with real numbers. Let me just write that. Okay, for that you need an imaginary number, which is something we don't study until about 3 courses up the road. We don't do them in 1075 anymore either. Okay, this is not a difference of squares just as it is. However, if we factor out the GCF 7, the rest is going to go pretty quickly. We've got that 7 outside. It's the square of x minus the square of 1. So it's 7 times x minus 1, x plus 1. When will this equal 0? When x is 1. This will equal 0 when x is negative 1. Those are your two solutions. And of course, and I haven't mentioned this, for any of these, you can take your solutions, plug them back in the original, and you'll see that they work. Plug in I don't want to plug that in. Plug in a 2 right here. 3 times 2 squared plus 5 times 2. 3 plus 2 squared. Oh, am I off the camera? Sorry. 3 times 2 squared plus 5 times 2. Does that really equal 22? That's 3 times 4 would be 12. 5 times 2 would be 10. 12 plus 10. You see, it does work. Okay. Let's move over here now to question 10. We need to get a 0 over here, so we'll take away 10 from both sides. And we need the good old AC method again. 3 times negative 10 is negative 30. And we need numbers that add up to plus 1. How about a 6 and a negative 5? Times those, you get negative 30. Add those, you get plus 1. 1x in the middle. No, 3x squared plus 6x minus 5x instead of 1x minus 10 equals 0. Common factor here is, greatest common factor here is 3x. 3x times x plus 2. Here minus 5 times x, also plus 2, because that'll make the minus 10. Now we have the factors x plus 2, 3x minus 5. When does this factor equal 0? If we would use a negative 2. And this factor, when we would use a positive 5 over 3. Don't forget, if you don't like doing this in your head, just set the thing equal to 0, like so, and solve it. You're going to get 5/3. You're going to add 5 and then divide by 3. You're going to get the same answer. Okay? Don't fall for this trap. Oh, negative 3, 5. No, those are not the solutions because we don't have a 0 over here yet. This is bad news. You can't do this until you first multiply these out, and you got to subtract 9 from, boy, this is going to take an hour. X times x minus 5x plus, oh, I'm so tired, I'm worn out, minus 15 equals 9. And then I can change that to minus 2x. And at the same time, let me take away 9 from both sides. Minus 15 minus 9, that's minus 24. That's better. What adds up to negative 2 and multiplies out to negative 24? I can ask it this way because it's just a 1x squared again. Have you got your numbers? Minus 6 and plus 4. See, those add up to negative 2. Those multiply out to negative 24. And don't get dizzy and say, oh, the solutions are negative 6 and positive 4. No, those are the numbers we're using in our factoring process. Now that we have this written as a product equal to 0, we say, when does this equal 0? When you would use a positive 6 for x, or a negative 4 for x for that factor. Okay? And again, plug either one of these into the original, you should get back what you started with. And the last example on page 2, there's a GC. Now this is not a rerun of number 9. Look closely, there's a difference. The GCF in number 9 was 7. The GCF here is 7x. 7x times x minus 1. Aha, big difference. It's all factored. When does this factor equal 0? When x is 0. 7 times 0 would be 0. So 0 is a solution and positive 1. Now, a lot of people think just because we get to a point where it says such and such equals 0, oh, plug in 0 for x, it's always going to work. No, plug in 0 for x here, it's going to say negative 24 equals 0. That's not true. See that? This one is different because you have this standalone some number times x as a factor. That's when you get a 0 solution. We got a 0 solution on page 1 when we were looking at this. This was not a quadratic, but it was all factored for us. We had a standalone x times a number. To a power doesn't matter, but that's the only time you're going to get 0 as a solution, is when you have a factor that's just either an x or an x to a power or a number times x to a power. As soon as it's x plus something, x minus something, those factors don't give you a 0 solution. Here I am talking too much again. That's the end of page 2.